So in the last video, we were talking about naphthalene, so make sure you watch the naphthalene part 1 and part 2 video before this one. We left off talking about how one of the pathways could be phase 1 O dealkylation, followed by, phase 1 O dealkylation, followed by phase 2 sulfation. So that was one of the pathways we just talked about in the last video. The phase 1 O dealkylation provided us with this aromatic alcohol that we said with aromatic alcohols or phenols, one phase 2 reaction that you should automatically think of is sulfation. And then we added on to our list that for sulfation occurs when you have aromatic OH, then you could have a phase 2 sulfation reaction. So now we're going to talk about another reaction called glycine conjugation. So glycine conjugation happens when you have a COOH. So whenever you have a carboxylic acid COOH, you can do glycine conjugation, because glycine conjugation is basically when you form a peptide bond between the COOH on the molecule and a glycine. So again, with conjugation, keep in mind that this is all endogenous molecules that are being added on to certain groups, and that's what I'm writing here in blue. So just to be consistent, make sure you're adding a list of adding this to your notes, what I'm writing in blue here, so you know when each type of reaction would happen. So with glycine conjugation, if you see a COOH, it is possible that the molecule will undergo phase 2 conjugation. So here I see a COOH in naphthalene, and that means that this can undergo glycine conjugation. And what that means is basically that your COOH group is going to turn into having this peptide bond with glycine. And we know that glycine is an amino acid. And so this COOH, I'm going to redraw that, is going to be a little bit different, because you're going to add a glycine, and if you remember, an amino acid has several components, right? And so you can look up a structure of an amino acid if you forgot what a peptide bond looks like, but I'm going to show you an abbreviated version. So this carbon right here, this circled carbon, is the carbon we want to focus on. So I'm going to redraw just part of the molecule, which is this sulfur part and this nitrogen. Just want to show you what's happening to that COOH. But you can assume that everything else is staying the same. Okay, so everything else, I'm just going to put an R group there. All the rest of this molecule is the same. We're just really focusing on that carbon that I have circled. So that carbon, when you do glycine conjugation, is now going to look like this. It's going to look like there's a lot of stuff added on, and that's because there is. Okay, so you're going to have all of this CH2 and H, and then you're going to have a COOH. Okay, so this looks really confusing right now, right? Because we went from a COOH, which we know looks like this, that's COOH, okay, and that COOH now turned into C double bond O, and then rather than having this OH, we suddenly have this big group. Where did that come from? That came from glycine. What does glycine look like? Glycine looks like, okay, so if you want to look up general structures of amino acids, that could be helpful. But glycine looks like this. It has the carboxy group COOH, and then you have your amino group NH2, which is what you see in all amino acids, and then you have, with the case of glycine, 2 hydrogens. Okay, and so glycine is then going to be added on to a COOH, right? So this group, this glycine group, is what we have, is what got added on to this carbon that we were focusing on. So that carbon now has the addition of this glycine group. And if you don't know how that happened, then you can look up peptide bonds and peptide bond formation. But whenever you have a peptide bond, if you remember, you're losing a water molecule. So what did we lose here? So if we zoom in on this carboxylic acid, this circled carbon right here is this carbon right here, and then there's a double bond O, and then there's an oxygen. But what did we lose, right? We lost this OH. Okay, this OH is what we lost. And then when it comes to glycine, glycine was what was added on. What did we lose from the amino group? Because it's the amino group of the glycine that formed a peptide bond with the COOH of our drug molecule, naphthalene. And so actually what happened is we lost one hydrogen here. Okay, so we lost one of these two hydrogens. And that's, how do I know that? Well, look, there's only one hydrogen there instead of two. And then we lost an OH. How do I know that? Well, I see C double bond O, and then I see that it's bonded to a nitrogen right away. So this OH was lost. One of these hydrogens right here was lost, and so I lost a water molecule, which is evidence that we formed a peptide bond. Okay, and then what you can do is you can draw out this molecule right here if you want to see how all the bonds are connected. But with glycine conjugation, you just want to focus on what's happening overall. Overall, what you need to know is we have a COOH. That means that we can have glycine conjugation. Glycine is an amino acid. So when the COOH of your drug molecule is going to combine with the amino group of your glycine amino acid to form a peptide bond, and then it's gonna be very obvious when this reaction has occurred, because if I just gave you this molecule and then I gave you this molecule and you just followed along to see what changed, you would notice that the change happened here. And you see the addition of this large group that has nitrogens, carbon, and then this looks like the structure of an amino acid to you. And so right away you'll know that a peptide bond has occurred, which means that phase 2 glycine conjugation occurred. Okay, and so in the next video we're going to go over a completely different drug molecule, which is butadiene. So this is butadiene. So you can pause the video, go ahead and see if you can predict what pathways butadiene will undergo. So see if you can come up with phase 1 pathway, like at least 2 phase 1 pathways and a phase 2 pathway, and then just draw out as much as you can based on what we just saw with naphthalene. See how much you can do with butadiene. And a good idea is have this list out and just see, like, can I do any of these reactions based on what I know so far and what I've learned in lecture or not. And then see how many you can come up with on your own before you watch the butadiene video.